It was a dark and stormy evening. Two scientists, Andrea and Isha, were walking home from a National Physics Convention. Suddenly, a UFO fell from the sky and a weird green alien emerged. And that's how we met Et from Dimension X. Hello, Et. You're probably wondering how the physics of our planet works, but don't fret. We are here to explain the three important basics you should know. These are known as Newton's laws. There are two important parts to Newton's first law. An object at rest stays at rest unless acted on by an unbalanced force. An object in motion will stay in motion unless acted on by an unbalanced force. Consider an index card on a cup. If you place a coin on the card and remove the coin quickly, the coin stays at rest and falls into the cup instead of moving along with the card, showing its resistance to the sudden motion. What would happen if you drove into a tree? Side note, please don't drive. Anyway, as this car crashes into a tree, you happen to fly out of the car. Although the car will be at rest, you will stay in motion due to inertia, your resistance to change in motion. Let's go on to the second law. The second law states that the net force, or the sum of the forces exerted on this object, is equal to the mass times acceleration, and that the mass of an object is inversely proportional to the acceleration of an object. Take, for example, if you and a bigger alien were both pushed by an equal force. Due to your smaller mass, you would have a greater acceleration, while the bigger alien with more mass would have less acceleration. Now, what would happen if mass was constant? Consider this. You are trying to push a mutant pumpkin, but it barely moves. Yet, when the bigger alien pushes the pumpkin moves further. Since you applied less force, the acceleration of the pumpkin was less, therefore it didn't move as much. Lastly, Newton's third law. Every action has an equal and opposite reaction. Suppose the big alien was standing on the ground. Well, why doesn't he fall through the ground? This is because the force of weight he exerts on the earth is counted by the normal force, which acts upward from the ground and is equal to the force of his weight. Also, if you look at the way a rocket launches, you'll find that the force that the rocket's engine exerts downward on the ground is equal and opposite to the force that the ground exerts on the rocket, which allows the rocket to launch upward. Now you know all about Newton's laws.